In this video, I'll be showing those that have never used Grasshopper before and are intimidated and think that it's a little bit scary, how to use it. I'm going to be going over these super basic scripts and showing you the power of parametric architecture and how it can be a super powerful tool for designing and to see all of your options when you're creating 3D models. So hopefully you find this useful. If you see anything or have any questions that are very critical to this tutorial, let me know. This is something I want to build upon and share with other people and get them started so they can become familiar with the process of parametric design and architecture. So to start, I want to talk about the fact that the more knowledge you have inside of Rhino in terms of modeling or drafting, the better you will be inside of Grasshopper, in the sense that all of the things that you see here, like the creating a line, creating a circle, a rectangle, all of these things are available inside of Grasshopper also. But if you don't know how to use them inside of Rhino, it's a little bit trickier to understand how to get them to function inside of Grasshopper. But that doesn't mean that you can't kind of play around inside of Grasshopper and see and learn new things that then you can translate into Rhino. So it kind of goes both ways, in the sense that one thing that you learn in one side kind of helps you understand the modeling, 3D modeling in general, a little bit better. So to start, the example I'm going to use is creating a rectangle inside of Rhino and showing you how to do that inside of Grasshopper. That way you understand how it works, one inside of Rhino and then the other one inside of Grasshopper. So let's say you want to create a rectangle here inside of Rhino. There are two ways to do that. You can first type in a command, rectangle, or you can click on a button that is the rectangle. So basically any command or any button that you click is going to do an operation, whether it's rectangle, point, circle. We're going to this time do a rectangle, so I'll click here on this button. Now that I've clicked, notice that first thing that we do is click on the button. So that's the first command, is find the button in the command that you want. Then it's going to ask you first corner of rectangle. So that's going to be the first operation, is where it's going to be located. So now we can either click somewhere here or type in here at the top 0, 0. Let's do that here. You can do 0, enter, and it'll do it at the origin, or 0, 0, 0, which is going to be the origin point, because technically we have here a coordinate system, x, y, and z. And so we're now going to do other corner length, so that's going to be the x. So here we can just say 30. Now it's going to ask width. Now we can plug in the next command, which is 30. So basically we've created a 30 by 30 rectangle at the origin point. This is fairly basic, but the output of what we have from the set of steps that we created was a rectangle. That is the output. Now we can't really change the size because we've just kind of clicked and gone through like a linear process. So we are now going to be aware of the steps that we took, which is click the button, now set the origin point, and then the length and the width. And we're going to be doing that the same thing inside of Grasshopper. So I'll take this and I'll use the gumball. If you don't have that on, click on this and you'll be able to drag that arrow to move this to the side. Now we can go into Grasshopper mode, and let me show you how to create this rectangle here inside of Grasshopper. To open up Grasshopper, go inside of Rhino and on the command bar type in Grasshopper, or you can go to this button here that launches Grasshopper. Once you do that, you'll see a file and there will be some default files for you to open. Just go ahead and go to File, New Document, and you'll see something like this. Now, as you can see, we basically have a open space, but this is different than what we see inside of Rhino. We don't have a coordinate system inside of Grasshopper. All we have is kind of this blank space, but this is going to function as the logic of the buttons and the icons that you see here. They're going to be created here, and this way it can be created parametrically. So first thing that we do, in the same way that we did it in here in Rhino, is we want to double click, and this is the way that you basically type in a command. So in Rhino, when you type in a command or click a button, the way to do that here is double clicking on the blank space. Now we can type in rectangle, and I can bring in this rectangle component, or I can go in here and cycle through the different tabs, which are going to give us different aspects of geometries and different transformation things that we could do. We want to look for curve, primitive, and we want to look for rectangle. So in the same way that inside of Rhino, we can look for icon and click it, or we can type in the command. We can double click, type the command, or go into the tab of, let's say, a curve, so two-dimensional curve, primitive, which means that it's going to be the basics, and a rectangle, which is going to be this component. Now there are different ways to view a component. First way to view it is going to be, I'm going to disable all of these, and you'll see that the component just says the name and has one letter for the input and one letter for the output. This is okay. Sometimes it's necessary, but for me, and in my opinion, the best way to display it is going to be enabling all of the raw icons, fancy wires, and full names. This way you can actually see the icon of what you're doing, and you can actually have a little bit more information for the input and the output. So now that we have this component here, notice that we have these little inputs and these outputs, and that's the same thing that we have when we click on an icon here. We have inputs, which is going to be the plane. This is the location base plane, and that's going to ask us where do we want to place it. Now Grasshopper by default, for the most part, will give you a default plane, which is the XY coordinate system, which is the same thing as this coordinate system that we have inside of Rhino. So the X and Y are going to be the same that are plugged in here. Now we can change that. We can bring in an XZ plane inside of Grasshopper and change the plane, but by default it'll put it here. Now we want to change the size. Now remember that for this rectangle we did 30 and 30, so let's do that here. Now to plug in inputs, we can either right click on that, set domain, and change the size, or we can bring in a slider. Now a slider is really important here for parametric design, and that's because this will give us a range of numbers that we can change. So if we have X and Y, we want to, let's say, plug in the X 30, and in the Y we also want to plug in 30. So this is where I'll double click here, and to basically bring in a slider, we can just plug in the number that we want. So let's say 30. It'll give me a slider of 30. Just notice that when you double click the slider, it'll say the minimum number is 0, the maximum number is 100, and it's going to set it at 30. Now what I'm going to do is plug that into both the X and Y, and notice that we've basically recreated that rectangle here inside of Grasshopper. The only thing that is different is the fact that when you select this, it turns green, and when you try to go to our Rhino file and we look in the viewport and I try to select this as hard as I can, and I cannot select it. And this is because when you've created it parametrically inside of Grasshopper, technically it's not an object that is completed, in the sense that it can always change. So think of it as clay. Clay can be molded until it's baked, and once you bake it, it'll actually turn it into the form that it's supposed to be, where it won't be able to move. So this is the same thing that we do in here inside of Grasshopper, where let's say I have a size of 25 rectangle. Well, I can click this, middle click or right click and bake. Then it's going to ask me which layer do I want to put it in. I'll just put it in the default layer. And you'll see that now I can actually click it and move it. And that's what the power of Grasshopper is that you can bake iterations. So now I can just move this around and then bake it and then move this around and bake it and just have iterations of different options just by moving a slider. So that gets you started with how Grasshopper works in the sense that I just wanted to show you how components are brought in, how components work in relation to Rhino. And from here, there's a lot more to be learned in the sense that there's a lot of different components. There's a lot of different ways to create numbers. But this is kind of getting your feet wet and kind of not getting scared and being afraid and intimidated by parametric design, because in my opinion, it's one of the most powerful tools that anyone can use. So hopefully you found that useful, and yeah, I'll see you on the next video. So going further with this exercise, let me show you the next things and the other things that we can do with this. So now that we have brought it in, we have given it an X and Y size. Now let's change the inputs. Rather than just one input for the X and Y, let's copy this slider and create a different Y size. So you can take the slider, Control C and Control V to create a copy. You can also drag this down here and then tap Alt or Option if you're in a Mac. And this way you get two sliders, and we can now plug that into the Y and have two different dimensions for the X and Y. You can also change the maximum and minimum if you want to limit the size to a specific amount. But now that we've created the size of this, let's change the name on the slider so we know what this does. Now that we have the slider of 35, we know that's the X size. So we can right click on top of that and change the name. So we can type in X size. And I use caps, but it's just a personal preference. And I'll go here to Y size. The other thing you're going to see is that when you bring in components, you don't have to use all of the inputs, but there are some critical inputs that you need to use for the component to work correctly. So what I do is for this one, it gives you a plane, world, X and Y, but we can change that location. So let's say you have a plane, X and Y, and we want to move it to X, 70. This is where we'll create a point. So I'll double click here and go to create point, or we can go to construct point. This way it's going to create a point, but it's going to ask us to input the X, Y, and Z. So we know that we want to move this in the X direction. And this is important, and very important, is to be aware of your coordinate system. So this is positive X, this is positive Y. So we want to move it in the positive X. This is where we'll take a slider, we'll create it here. So we'll double click here and go to 70 and plug that into the X. And as you can see, it creates a point at that location. Now we can plug in that point into the plane and see that we've successfully moved it in the X direction. Now if I plug in both X and Y, you'll see that it will actually move it diagonally, because when you have X and Y, it's actually a slope. And in the same way that if you do a Z, it's actually moving it up in that direction. So this is how you can change the location of this plane by changing the input of its location. Now, this point say we move it here, but it says X, Y plane. Why don't we change it to a plane that is X, Z? So if I double click here and bring in a component X, Z plane, we'll see that this component has one input and one output, and the input is going to be the origin point, which is the point we created up here. Now it creates a plane, and this plane can be plugged into this plane output. And now notice that it actually creates it not on the ground or relative to this X and Y coordinate system. Now it's actually created it off of the X and Z coordinate system, which is a component. So every component, we can now use this component, which is a reference plane, and use that as the input. So just wanted to show you some of those aspects of basically referencing multiple planes and changing the location of that. So at this point, what we've done is change the origin point. We can unplug components, inputs and outputs, by bringing this back out and holding down Control, and you'll see a negative sign, which means that it will remove it. And now it only has the X and Y. We can remove the X and just have this. Now, in the same way that we have one input in the X, let's say we want to take this and create two rectangles. Well, we can copy and paste this, and holding down Shift, we can add more inputs to one input, which means that we can create two rectangles by putting two inputs into the point that then creates the reference plane that is then creating the rectangle that we can change the size of. So all of this is tied together parametrically. And lastly, for this exercise, we can change, of course, the location here. So this is going to be the name of location 1, and this will be location 2. Lastly, when we have a rectangle, notice that we have some outputs here. Now, not only is it important to be aware of the inputs and the information that we put in, we also need to be aware of the outputs and the things that come out. So with this component, we have a point that comes out, and this is why we have 2 points, because we have 2 X coordinates plugged into the sliders. Then that point then creates that origin plane, where then we have this rectangle. Now this rectangle will give us an output, which is the rectangle, which is what we see, and also a length. When you hover over an output, you'll see information regarding that output. For this one, it says 2 locally defined values, a rectangle giving you the width of one of the rectangles, and then the second one giving you the width and the height of the other rectangle. The length is going to give us the length of this rectangle and the length of this rectangle, and sometimes that's important depending on what you're trying to do. So with that, let's go to the radius, and this, sometimes it'll say radius and you'll be like, what is it asking? So when you hover over the input, it'll say rectangle corner fillet radius. What that means is it's going to round off the edges. So let's go here, double click, and this is where you can also plug in a number using a decimal value. So I'll just go here to 3.50 and change this and plug that into the radius. And notice that when you do 2 decimal points, it'll give you a slider with 2 decimal points. But when you pick a number between 0 and 10, it'll give you a minimum and max of 0 and 10, and it'll place that number there. When you do it larger than 10, it'll actually create a number between 0 and 100, and so on. With that being said, let's change this to fillet. And this is another way in which we can round off the edges or further change the output by plugging in a different input for the radius. Now you can always go to 0 and have a perfect rectangle, but as you can see, it's good to see how all of this is tied together and how this kind of works parametrically. And these are what we're working with are the basics down to we're working in parametric design, we're working down to the basics and back to understanding the origins of how things are created. And from there, understanding that this is not necessarily a linear process where you go from beginning to end. You actually can always change the inputs, therefore not being a linear process, more of a spiral coming back into the process. So thank you very much for being here for this video, and I'll see you in the next one. So now that we've made it this far, we've created 2 rectangles using this algorithm. The next thing we're going to do is create a surface here and then extrude it to give it some 3-dimensionality. So to create a surface, the component that we are going to bring in is called boundary surfaces. So I'll double click here and go to a component, like I said, boundary surfaces, which will create a rectangle or create a surface along a closed polyline. So this rectangle is going to be our closed polyline. We can use that and create a surface. Now notice that our previews are always in red. These are things that can be changed if you go to display and other settings, but by default you will see that they are red. And you will also see things like this kind of checkerboard thing, and that is actually a reference plane. That is this, and you can right click and disable preview. This way you don't have to look at those things if you don't want to. You can only preview the things that are important to you. So right click, disable preview, or select it all, middle click and do the guy with the bandana over the eyes to hide everything. Or let's see, what was the other way? I think on a Mac it's not middle click, it's going to be spacebar. There's a way to get like this is called the radial options, so you can disable the preview so you don't see it. Now that we have this surface, that was fairly straightforward. Just make sure that if it's going to create a surface, it has to be a planar. That means that it has to be on a 2-dimensional surface. It cannot be anywhere outside of that. There are other ways to create a surface on that, but with boundary surfaces, it's only going to do it on a 2-dimensional flat boundary curve. With that being said, let's take this and extrude it. Now, when you bring in an extrusion, so double click here, extrude, and we'll extrude this surface. So plug that into the base. And notice that the input, it doesn't say surface, so you'd go like, oh, it doesn't say surface, it's not going to work. Well, the base is going to be just a geometry input. You can extrude surfaces, you can extrude curves, things like that. So it's going to ask for a direction, because in the same way that in here inside of Rhino, if we type in extrude, it's going to ask what curve and in which direction. And sometimes it does up, sides, and you can change the direction. Well, we need to be aware that these rectangles are actually aligned in the YZ plane. So we actually want to extrude these in the Y direction. This is where we'll double click here and bring in a unit Y. So I'll just click on Y and it'll bring in the option to bring in unit Y. Let's bring that in. And by default, when you bring in a vector, it's going to, by default, the input's going to be 1. So let's change that by changing the input. Now I'll take this and copy it. So I'll slide it here, tap Alt, and change the name to extrude. Now let's plug this into here. Now it's extruding by 0. Now it's extruding more. Now what's cool is that you can also, let's say, do something like this, where you can say whatever radius So these are some of the things that you can type parametrically, which I feel like kind of the cool thing to have that ability to change things to see if they look good or not. And so with that concludes kind of the overall getting started lesson. If you notice something that I didn't go over, you got stuck somewhere, please let me know. This is something I want to build on and help new people get started using parametric design. It's a little bit intimidating at the beginning, but like I've said before, it is some of the most useful things to understand and to get used to if you're trying to do architecture and things like that in the future. If you enjoyed that content, make sure to subscribe for future videos and also check out the website for more resources. I will have this script available to download on the site, just so you can have it side by side, just in case you're not able to kind of plug in everything and get it working.